Okay, so this is the 2025 Higher Level Maths Leaving Cert Paper 1, question 8. So Jacob buys a new kayak in a shop. The kayak is usually priced at €870. This price is reduced by 15% in a sale. Jacob gets a further reduction of 10% on this reduced price because he is a member of the shop's loyalty club. Find the price that Jacob pays for the kayak. Okay, so it's usually priced at €870. So you've got to reduce that by 15%. So if this is 100%, really what we've got to do is multiply that by 0.85. That'll bring it down to €739.50. Now that €739.50 is going to be further reduced by 10%. So you got to multiply that by 0.9. When you do that, you get €665.55. So this is the price that Jacob actually pays for the kayak. Let's look at part B. Jacob buys a paddle online. The paddle costs $95. Jacob thinks that the exchange rate being used is €1 is equal to $1.183. The actual exchange rate being used is €1 is equal to D dollars. D is real. As a result, the paddle costs €1.02 more than Jacob thought that it would. Use this to find the value of D correct to 3 decimal places. Okay, so if we take the exchange rate, the actual exchange rate here being used, which is D dollars. So D dollars is equal to €1. So $1 would be 1 over D euros. And then the paddle costs $95. So $95 then would be just 1 over D times 95, which is 95 over D euros. So this is the amount that Jacob actually paid in euros. Let's look at the amount that he thought he paid. So let's take the other exchange rate. $1.183 is equal to €1. So $1 would be equal to 1 over 1.183, and then $95, which is what it cost, would be equal to this here multiplied by 95, or just 95 over 1.183, and this is in euros. So this is how much he thought he actually paid. So it says, as a result, the paddle cost €1.02 more than Jacob thought that it would. So you've got to just look at these two values that we've worked out. So in other words, we can say that 95 over D, the amount that he actually paid, is going to be equal to the amount that he thought he paid, 95 over 1.183, plus another €1.02. So all we got to do is just solve this for D. So you got 95 over D is equal to, well, you can just work all this out on your calculator. It's 81.32431107. You can multiply across by D, so the D would end up here, and then divide by this here. So you would actually just end up with D on this side, and then on the left hand side, I think we have to do this to, is it 3 decimal places? Yeah, so we've got to do this to 3 decimal places. So let's just do that. So D would just end up being 1.168, and that is in dollars. So that's your exchange rate then. €1 is equal to $1.168. Okay, next question then. Jacob takes part in a race which involves kayaking and running. He must get from the point S in the sea to a point F on the coastline. A is another point on the coastline. The distance is 2 kilometers, and then we got 8 kilometers, and the angle is a right angle. Jacob kayaks at an average speed of 6 kilometers per hour and runs at an average speed of 12 kilometers per hour. Find how long it would take Jacob in total to kayak from S to A and then run from A to F. Okay, so this is just a simple kind of a speed distance time kind of question. So you've got speed is distance over time. So we want to find time then, so we know that time is distance over speed. So we got to do this twice. So you got to look at the kayak part of the race. So the time is just going to be the distance, which is 2 kilometers. He does that at 6 kilometers per hour. So that is just 1/3 of an hour. Okay, then the run. So again, the time is going to be the distance, which is 8. He does that at a speed of 12 kilometers per hour. So that is 2/3 of an hour. So the total time is just 2/3 plus 1/3, which is just 1 hour. Okay, next question then. Find how long it would take Jacob to kayak directly from S to F, correct to the nearest minute. Okay, so what we've got to do is we've got to imagine that Jacob is going directly from S to F, so we need to find how long it's going to take to go from S to F. So we've got to find this distance first anyway, so we've got to use Pythagoras' theorem. So it's going to be 2 squared plus 8 squared is equal to SF squared. So the distance is going to be the square root of 2 squared plus 8 squared. So we have 2 squared plus 8 squared is equal to the distance from SF squared. So the distance from S to F is just going to be the square root of 2 squared plus 8 squared. So that is SF. So that is just 2 root 17, and that is in kilometers. Now the time then is, the time again is just distance over speed. In this case, the distance is 2 root 17. The speed again is 6. So when you do that, you get 1.37436 and so on. And this is in hours. So we need this, let's see, it says correct to the nearest minute. So it's going to be 1 hour anyway. And then you can just multiply this by 60 and you'll get 22 minutes. So it's 1 hour 22 minutes. You can also use the degrees button on your calculator to convert this to hours and minutes. But anyway, it's 1 hour 22 minutes. Okay, this is part E1. The point B is on AF. AB is X kilometers, where X is between 0 and 8. Jacob is going to kayak from S to B and then run from B to F. Find an expression in X for T, the total time in hours that it would take Jacob to get from S to B and then to F. Okay, so first of all, we've got to find the distance from S to B. And to do that, we're just going to use Pythagoras' theorem. So again, the distance from S to B, if we square it, is going to be equal to 2 squared plus X squared. So the distance from S to B then is just the square root of 4 plus X squared. Now the time it takes to get from S to B is distance over speed. So the distance we've just worked out as the square root of 4 plus X squared. We got to divide that by the speed, which is just 6. And again, this is in hours. Now, he's going to run then from B to F. So we've got to work out the time it takes to go from B to F. So the run time, again, is distance over speed. The distance is 8 minus X. And the speed that he runs at is 12 kilometers per hour. So this is hours as well. So we have our total time then. Total time is just equal to the square root of 4 plus X squared over 6 plus 8 minus X over 12. This is the total time and this is in hours. Now we can add these. Let's see, we would have a common denominator of 12. So that would be 2 square root 4 plus X squared plus 8 minus X. And again, that's in hours. Okay, next question. Jacob knows that there is one value for X for which T of X is a minimum. X is between 0 and 8. Solve the following equation to find this value of X corrected 3 decimal places. So this is just a case of solving this equation. So we got X over 6 times the square root of X squared plus 4 minus 1 over 12, and that's equal to 0. So let's just bring that 1 over 12 to the other side. So we have X over 6 times the square root of X squared plus 4 is equal to 1 over 12. We have a fraction equal to a fraction here. So what we can do is just cross multiply. So we get 12x is equal to 6 times the square root of X squared plus 4. Now I have that 6 multiplied by the square root. So I'm going to divide both sides by 6. So I get 2x is equal to the square root of X squared plus 4. Now what I'm going to do now is just square both sides. So I've got 4x squared is equal to x squared plus 4. Bring that x squared over to the left hand side. That gives me 3x squared is equal to 4. That'll give me x squared is equal to 4 over 3. So last step then really is just to square root both sides. So that gives me x is equal to plus or minus the square root of 4 over 3. Now it says up here, I think somewhere, that x has to be between 0 and 8. So x has to be positive. Distances are positive. So I need to take x as being plus square root of 4 over 3. We've got to do that on our calculators, so that gives you 1.1547 and so on. And we have to do this to 3 decimal places. So we want our answer correct to 3 decimal places. So our answer then is x is 1.155 and it is in kilometers. Units are important here. You may lose a mark if you don't put in these units. So that's 3 decimal places there. The number after the 4 is a 5, 6, 7, 8 or 9, so you need to round up that 4 to a 5. Okay, let's look at the next question then. There are no other values of x in the interval 0 to 8 for which t prime x is equal to 0, apart from the answer to part E2. Use this fact and your answers from parts C and D to find which one of the following graphs could represent t of x for x is an element of the interval 0 to 8. Justify your answer fully. So I'm saying the answer is D here, and I'm giving a reason here. I've written it out already. Now we're told that there are no other values of x in the interval 0 to 8 for which t prime of x is equal to 0, apart from the one answer that we got in E2. So that means there's only one turning point. Here you can see there are 2 turning points. Here you can see there are 2 turning points. But in C and D, there's only one turning point in each one. So there's a turning point here, there's a turning point here. So why did I pick D then? What I'm saying here is the graph C and D have only one turning point and they're both local minimums. Now also from part C he took 1 hour. So in part C he took 1 hour, and that's when he went straight down perpendicularly to the coast, if you like. So the angle was a right angle, and then he went straight across to F. So that was where he took 1 hour. Now, when he didn't go straight down perpendicularly to the coast, it took 1 hour 22 minutes. So from part D, he would take 1 hour 22 minutes. Therefore, we need a graph where there are times greater than the time at x is equal to 0. At no stage in graph C are there times greater than at x equal to 0. However, there are in graph D. So you can see in graph C here, as we increase x here, there are no times here that are greater than at x is equal to 0. Whereas here, we could have a 1 hour 22 minutes up here somewhere. So at x is equal to 0, this is where he took 1 hour, and then he took longer as x gets bigger out along here. Okay, so that's my solution to the last part of this question.